I see your question, Jen. I'll come back to it. Okay. 300, 330, 360. Okay. Yeah, I don't think Hannah's here right now, though. So Amelia should have noticed that. The ordered pair here is if we're going to graph it, Jenna. If we're going to graph it, this would be the X component, this would be the Y component. Okay? Does that make sense, Jenna? We're going to get to graphing it, so we can take a look at it. So what I want you to do is you can plug in any one of these numbers and you give me back the number it is. So for example, if I did 240, I'd write 240 and maybe equal sign and then give me the number that it is. Okay? And give me that, and then I'll plug them all in on my screen. Okay? This was 1. For which one, Kyle? What did you get 0 for? I need the angle to go with it. For 360? Okay. 360 is 0. 360, comma 0. 270 is -1. -1. 270 is -1. Sage, I need to know what your number was. Oh, 210. 210 was, double check your calculation, Sage. It shouldn't be that. I think you're missing something out of it. No, not degrees. It should be a negative number.
When I do negative, it does that. Like when
Pardon?
I put the negative, when I put the negative, it turns to degrees, like when I type it.
If you just go
But it's
sine
supposed to be
210?
No, I mean like, just in here.
Oh, I understand. Okay, I got you. Okay. Negative 0.5. So that's 210, comma, negative 0.5. 330 is -30. All right, interesting. Uh, 150 is 0.5. Okay. Negative, yeah, okay, cut that one. Can someone predict what 300 is going to be? Actually, let's do 120 first. Someone do 120 for me. What do you get that? Good, so 120, 0.8, I'm going to round to 7. Did anyone do 180? What do we have for 180? 0, good. Now with that knowledge, if we take a look at what numbers are coming up here, what number do you think is going to go in this spot right here? Oops. Oh my gosh. Stop it. All right. Crashed. Open back up. Good. Okay, let me see here again. So what number do we think is going to go in this spot right here? Look at the pattern that's going on. What's the next number to go in there, do you think? Good, Owen, but I will agree with you, but disagree with you. What are you missing on that? Negative, good. And then this one would be negative 0.87 as well. Now, one thing you notice was there's a pattern here that kind of repeats itself, right? And it kind of makes sense because if you look at our Freddy the Frog here, or if we call it Brooke the Frog, right? When it's at 30 degrees, we're at 0.5. And if you look, 30 degrees is the exact same difference, but the opposite at 330. And if we look at 330, we're at negative 0.5. Does that make sense to everyone? So as we go, each one's gonna have a partner. Like when we're at the very top, we're at the very top, so that's 1 meter above, which kind of makes sense here. We're 1 meter above the water. But then we're at the very bottom at 270, we're 1 meter below the bottom. So does everyone kind of see the pattern or kind of make sense of the heights? Now, when you see you got 180 with 0, well, that kind of makes sense because 180, you're at the same water level again. Put a Y in chat if you can kind of make some sense of what's going on here. So you can kind of connect with, okay, at 270, I understand how he's 1 meter underwater, right? You can kind of picture, okay, 300, yeah, that makes sense, or about 8.6, and that kind of makes sense because it's the same amount as 60 and 120. It kind of has partners all the way around, right? I'm going to show you this. There's our frog right now riding around. Okay, I like my frog better than that frog. I'm going to skip ahead to the one I want. So we did this already. We didn't do every 15 degrees. We did every 30. But if you look, this dot here is a height dot, okay? If you look as we go, it kind of makes a pattern where it goes up, and then we start to go down, then back to the middle. Does everyone see that pattern as we go? Up, down, back to the middle. And if we connect it with a line, it's a little more obvious. Right, at 180 degrees, we're back to the middle, right? Then we go all the way down, and then we go back. And if little Freddy stayed on here forever, he would just keep repeating this pattern over and over and over again. Unfortunately, it doesn't go multiple times. Right, so there's our frog going up, frog going down, then back up to the middle. And you can see it's kind of connected with the degrees that we go. Okay. Where's my worksheet? Now, down here, you can sketch a little graph for me, actually. And I can sketch it because you guys hate sketching. Right, sketch this on your sheet just for a good reference. So what I do usually is, if you look at our data, the main points are at 90. Every 90 degrees is an easy point to graph. as in 0, -1, 0, 1. Does that make sense? Like the 30 and 60 are all good, but the easy ones to graph are the 90-degree ones. So if I were making a sketch, I would mark off all my 90 degrees. So 90, 180, 270, and 360. Okay. I'll go with green since he's a frog. Now the highest he gets is 1. The lowest is -1. Put an S in chat right now if you want me to slow down. Okay. So if he starts at 0, which makes sense, I didn't put 0 there. At 90, he's at 1. So I can put a dot right here. Okay. So we're just going to sketch the big ones. This is just as a reference. So at 90, he's up at 1. At 180, he's about to go back. He's right at the water level again. At 270, he's way at the bottom of the wheel. And 360, he's back at the beginning. So you could sketch this little graph. It should look something along those lines. Put a U in chat if you understand how I made my little sketch. Okay. All right. I'm going to grab my little sketch and bring it down here. So this is what a sine graph, a sine function looks like. Okay. Sine function looks like you go up, middle, down, middle. And if some people, a couple of kids in my class last year really like that. We're up, middle, down, middle. If you kind of remember that, sometimes these two letters change when we get going in the future, but up, middle, down, middle. So you can go up, middle, down, middle. And if you kind of know those up and down points, then you're kind of rock and roll. So a couple things here that we're going to learn about. Okay. We did this one. We did this. These are some definitions we're going to learn with. Okay. I'm not going to do them in order. Who thinks they can tell me what my max is? What's my max of my graph right now? Who thinks they can tell me what Freddy's max is? Perfect. Freddy's max is 1, which occurs right here. So the max would be the highest point on your graph. What's the minimum? My minimum is -1. Perfect. Right? And my minimum is my lowest point. I'm not going to deal with this. We can work with domain and range. All right. Here's an interesting one we haven't learned yet. What's the period of this graph? So the period is how long for one rotation. Okay, and this is an x value. Who can tell me what the period is? How long does it take to go through one full rotation of this graph? Perfect, D. D, you're killing it today. 360 degrees, right? Would be how long it would take for one rotation. So all the way from here to here is 360. Now amplitude is from middle to top. Okay, from the middle to the top. So my amplitude in this case is 1. Because from the middle of my graph to the top is 1. Okay. And lastly, we have domain and range. If you remember back from the very first of the whole year, we talked about, we'll do range first. Range is up and down, right? So we would say from 1 to -1. We're just going to do it in words right now. And then for this one, my domain would be, I'm not going to worry about domain and range today, in all honesty. I'm introducing it, but we're not going to worry about today. Domain would be from, in this case, from 0 to 360, assuming that Freddie hops off. What do I want to do with you right now? Okay. I'm going to pull up a better chart for this. Okay. Well, first things first. I want to take a look at this definition first. Periodic. Okay. A periodic is a graph that repeats itself, okay, over and over and over again. One second. So for example, a periodic graph, and we can only do stuff with periodic graphs. We can't do stuff that is not periodic. Let's grab this one. And I'm going to grab this one. Oops. So you have an option A. Oops. Option A or option B. Which one of these is periodic, as in it self-repeats all the way across the graph? Don't press enter. Put the one you think is periodic. Oh, Emma. Which one is periodic, A or B? That's no problem, Emma. Ready? 3, 2, 1, press enter. Logan says A. Brooke says A. Good. Good, because this one looks the same all the way through. This one, it looks the same, but it's getting smaller. Bonus question, what's getting smaller here? The domain or range? Which one of these is getting smaller as it goes through? Very good, Avery. Range. Let's see here. I'll show you the most important periodic graph you'll ever see. And bonus points for, Jack will know what it is, actually. Jack will know what this is. So Jack, you're not allowed to answer. I assume Jack knows what it is because I think you took kin first quad. Oh, how'd you know that, Emma? Oh, Grey's Anatomy. Oh my gosh. Okay. Is this periodic? Yes or no? The answer is yes. Because if you just looked at this section here, you have to kind of chop it off in a spot. Now, I agree with you if you didn't think there was a trail there, right? But if I cut this off right here, right, knowing that there's a lead in there, this looks just like that. And hopefully it keeps repeating itself. If it doesn't, you have an issue. Let me look at a heart attack ECG. It's when you don't see a rhythm there that you actually get in trouble. Okay, where's some other ones? Actually, let's do some of your homework questions. Pateo, do your homework. Is that okay? So just looking at these ones. Please type in and do not press enter. Do not press enter. Which one of these are periodic? Which one of those is periodic? On the count of 5, 1, 3, 5, go. A and B are periodic. A and B are periodic. A, B, A, B. Good. So A, B are both. There's 3 of them there, D. You're like my daughter trying to ask her what team she's cheering for, and she says both of them, so she always wins. Okay. Good. Not all of them. This one isn't. This one's going up the whole time, right? And it's going to go up forever here. All right? It needs to repeat. So this would be periodic. It would have to go something like this. Like have to like drop off and then go again. Does that make sense? Periodic means a graph that repeats itself, essentially. So let's go back to our notes section here. Where am I? Okay, I'm going to make a better, get a blank piece of paper out that you can write a note on, okay? A keeper piece of paper. Where did 7? Periodic functions or sine function is what it will be. So give me one second. I want to look at something. No, we're going to stop it there. Okay, we're going to take a break for do you want to go 10:20 or 10:30 to come back at? Okay. So 10:30 is when we're coming back. How many people would like me to email them this sheet so they don't have to print it out? Not a chance, Brooke. Trust me, the next section is going to be super quick. You guys should be done by done your homework at 11:15. Okay, I'll email this out to the class. If you can't print this, oh Haley. If you can't print this, you are to